Okay, so the rest of this term we'll spend discussing our own little neighborhood of the universe, the solar system, which includes sun and other bodies that revolve around it, in particular planets like our own. You are probably aware of the fact that astronomers these days find these so-called exoplanets, the planets that exist around other stars. And as the time goes on, they are discovering more and more, and the estimate is that 1 in 6 stars in our galaxy has a planet or planets. Now, if you think about the number of stars in our galaxy, which is 100 billion or so, 1/6 of that is a pretty large number of planets that should be there in our galaxy. And certainly the same should happen in other galaxies. So considering the large number of planets, it is quite possible, in my view, that there is life out there in the universe somewhere, right? That we are not the only ones. Okay, so I'll start with chapter 8 from your textbook. And let us first see what is in the solar system. So first of all, the sun. It is the largest object in the solar system, as you can appreciate from this picture here, which is a composite of actual images of planets drawn to scale, and here at the edge there is a piece of the sun. So it's clearly the most dominant object in the solar system. 99.9% of the mass in the solar system is contained in the sun, right? Its mass is about 2 times 10 to the 30 kilograms, or about 300,000 times larger than the mass of the Earth. So in terms of its mass, the sun dwarfs everything else that is there revolving around it. Here you can see 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Of course, what is presented here are the planets drawn to scale, but their distances, or the distance from the sun, are not drawn to the scale, just so that we can fit them all together in one figure and compare their sizes. In addition to planets, there are also so-called dwarf planets. Pluto and this one here, now called Eris, are examples. Also, the largest of the asteroids in the asteroid belt is also classified as a dwarf planet, although I still prefer to call it an asteroid. But and we'll discuss the reasons why in 2006 Pluto was demoted from the status of planet to dwarf planet. Okay, it was basically the discovery of this object here, which was initially labeled 2003 UB313, and then it was given the name Iris. So the question arose as to what shall we do? Whether we should say that there is 10th planet in the solar system, or shall we demote Pluto from its status of the planet? And I'll describe what happened. In addition to its having enormous mass, it also has a large diameter. The diameter of the sun is about 110 times larger than the diameter of the Earth, or about 10 times larger than the diameter of Jupiter, which is the largest planet in the solar system. Okay, here is Jupiter, clearly the largest of all planets, but nevertheless its diameter is 10 times smaller than the diameter of the Sun. So the Sun dominates not only in terms of its mass, but also its dimensions, its diameter. As I mentioned earlier, we have 8 planets which are moving in nearly circular orbits around the Sun. Those of you who took Astronomy 1P01 will recall when we talked about the history of astronomy that it was Johannes Kepler who found 3 laws that describe the motions of planets. And the first one, which refers to their shapes, says that their orbits are of elliptical shape, slightly deformed circle, and it turns out that deviation from the perfect circular shape is rather small. Right? In the case of the Earth's orbit deviates from a perfect circular shape by about 2%. So the planets revolve around the Sun in nearly circular orbits. Again, in this figure here, the planets or their distance between each other and the Sun is not drawn to the scale. Everything has been compressed so that we can fit in the entire solar system. And in addition to planets, what you see here in this region between the orbits of Mars and Jupiter is so-called asteroid belt, where most of the asteroids live, at about 2.5 astronomical units away from the Sun. There is also a comet. That's another type of object that one has in the solar system. And then beyond the orbit of Neptune, between 30, the distance between the Neptune and the Sun is about 30 astronomical units. So between about 30 and 50 astronomical units, we have a region that is called Kuiper Belt. The 2 dwarf planets, Pluto and Eris, also included. And astronomers knew for the long time that Pluto is quite different in many ways from the other 8 planets. And they thought before Pluto was demoted that it should more properly be considered as a Kuiper Belt object. That is one of many bodies that reside in this region here between 30 and 50 astronomical units away from the Sun. And it is basically this region here contains the nuclei of what are called short period comets. These are basically what happens is that one of these objects, which is composed mostly of ices of different gases, methane, ammonia, water, and so on, mixed in with some silicate materials, it gets kicked into the inner part of the solar system and starts revolving around highly elliptical orbit around the Sun. And when this object gets close enough to the Sun, say inside the orbit of Jupiter, it receives enough heating from the Sun so that these ices start to evaporate, and the object develops a tail, which is the comet's tail. Right? And usually these comet tails are visible for a long period of time, several weeks, months maybe. In fact, recently there were possibilities of even us here seeing a comet, and it turned out that actually it was visible from our latitude only for a very short period of time near the horizon, and you still needed the binoculars to see it. But sometimes they are observed with the naked eyes, and throughout the history, their appearance, people tended to assign or associate with some bad events, where one country gets invaded by another country, so they were treated as omens. Now, here I give a list of planets and their approximate distance from the sun. And there are two groups of planets. The first group consists of Mercury, Venus, Earth, and Mars, and they are collectively called terrestrial or Earth-like planets. And their distances from the sun in astronomical units, and I'm just giving approximate values to one significant figure or two when needed, because that's all you need to know. So the Mercury is at about 0.4 astronomical units away from the sun. Venus, slightly more distant, well, twice almost as distant as Mercury at 0.7. Of course, in these units, we are one astronomical unit, and Mars is at 1.5 astronomical units. And then the second group of planets, right, are Jupiter, Saturn, Uranus, and Neptune. And they are collectively known as Jovian or Jupiter-like planets. And their distances are, for Jupiter, it's about 5, for Saturn 10, Uranus 20, and Neptune 30. Then we have these so-called dwarf planets, Pluto, which is at about 40 astronomical units away from the sun, and Eris, that was finally discovered in 2005, although the first sort of recognition that there is something out there was made in 2003, and it is at about 100 astronomical units away from the sun. So now coming back to this question, why is Pluto no longer considered to be a planet? Yeah? And as I said, the discovery of Eris in 2005 put astronomers into a dilemma what to do, whether to include this newly discovered body into the set of planets to be a 10th planet, or to demote Pluto from the status of the planet. And then they decided they have to set up some kind of criteria that a body revolving around the sun should satisfy in order to be classified as a planet. So in 2006, International Astronomical Union met, and they came up with the following criteria for a body to be considered as a planet. The first one is kind of given. I'm not sure why it's even there. It says that it has to revolve around the sun. Of course, every object in the solar system, including comets and asteroids and meteoroids, they are all revolving around the sun. So to me, this one is kind of silly. The second one is meaningful. It has to be large enough. It has to be large enough, massive enough, so that it assumes a spherical shape under its own gravity. Smaller bodies, like asteroids, they don't have spherical shape. Often they have an irregular shape. Often they look just like a potato, right? Or large, very large stone. So for an object to be a planet, it has to be massive enough so that its own gravity compacts it and makes it into approximately a sphere, a round object. And the third one, which actually did it to Pluto, it has to be the only body of that size at that particular distance from the sun. In other words, it has cleared its orbit. There is nothing else there roughly at that distance from the sun because presumably that object scooped all the other material that was there originally. So as you can perhaps see from that previous slide, okay, there are many, many objects in Kuiper belt, okay? So Pluto clearly has not cleared the orbit. There is Eris there, right, which is comparable in size to Pluto, and so Pluto failed that third criterion. So that's what was used to demote Pluto from the status of full-fledged planet and demoted into the status of dwarf planet. Now, personally, and that's just my personal view, that is splitting hairs, okay? How we call a body, whether, you know, which precisely criteria we use, it doesn't matter, it's there, okay? There's nothing profound there to actually, you know, it's the same object, whether we call it a planet or a dwarf planet, right? And as I mentioned before, astronomers knew for a long time that it's very different from other planets and that should perhaps be treated as one of the Kuiper belt objects. But I'm just telling you this so that you know, there were, you know, people who, in particular in US, because Pluto was discovered by an American astronomer in the 20th century, and there was a lot of sort of emotional reaction to Pluto no longer being considered a planet, right? But it is what it is. Now, planets may have satellites, bodies revolving around it, and they could also have rings. So already here you can see the difference between terrestrial planets, Mercury, Venus, Earth, and Mars, and the Jovian planets, Jupiter, Saturn, Uranus, and Neptune. Mercury has no satellites. Neither does Venus. We have one, our moon, and it turns out that Mars has two. But the satellites of Mars are very different from the satellite of Moon. Okay? They're much smaller, and they look to be captured asteroids. While the Earth-Moon system was most likely formed in a catastrophic event when early on, after the solar system was formed, the place was really crowded. There were lots of collisions, and at that time, early on, Earth was probably struck by another body, probably of the size of the Mars. It was sort of a grazing hit. And some of Earth's material was evaporated, it condensed to form the moon, was kept revolving around the Earth by the force of gravity. But these two satellites of Mars did not rise that way. They are most likely, as I said, captured asteroids because they look like asteroids. They're irregular in shape. And then no terrestrial planet has rings. None of these four planets has planetary rings. On the other hand, the Jovian planets have many satellites. Jupiter has 63 and counting. I mean, I've been teaching astronomy off and on since early 90s, and in particular, I started off by doing the section on the solar system, and over the years, this number has been increasing all the time. And the reason is that the small satellites of a planet are hard to see, right? Because of their small size, they don't reflect much light. So we receive much less light from them. And you need dedicated good telescopes to actually be able to spot them. So for now, this number is 63, but will probably grow in the future as smaller and smaller satellites of Jupiter are discovered. The same with Saturn, right? Uranus also has a large number. Neptune has more than 10, right? All these numbers could likely grow in the future. And all Jovian planets have rings, all of them. Okay? So look at the difference. Terrestrial planets, no or very few satellites, definitely no rings. Jovian planets, all of them have certainly more than 10 satellites, and they all have rings. Okay? Now, just a side note, my discussion of the solar system, rather than going from one body to another and discussing its details, what I find more interesting and perhaps more useful for somebody like you who is learning the subject for the first time, instead of getting lost in details, you should actually see what the trends are there and what these trends tell us about the formation of the solar system. I think that's much deeper knowledge than knowing the particular details of any one of these individual planets. So that's going to be my approach. Okay, so some images. Here are some selected satellites in the solar system, and our Earth here, and everything is here presented to scale. Okay, so you can compare the size of these different satellites to the size of our Earth. Here is our moon, and for Mars, the two satellites Phobos and Deimos, which are Greek words for fear and terror, are so small that you can't really see them on this scale. They are much, much smaller than our moon. They put in here, for whatever reason, the satellite of one of the asteroids. In fact, it turns out that a fair number of asteroids do have their own satellites, the larger ones. Then here are the four largest satellites of Jupiter: Io, Europa, Ganymede, and Callisto. And they are commonly referred to as Galilean satellites because they were discovered by Galileo Galilei when he pointed his telescope in 1609 into the sky and made fantastic discoveries that changed the view of the universe. Not immediately, but over time. And of course, there are many, as you saw in that list, there are many more, but they are much smaller, right, than these four. Here are some of the satellites of Saturn. Here is the largest one, the Titan. And there was just recently in the news that astronomers have, for the first time, observed there are seas of methane. The surface of Titan, parts of it are liquid, and it's a liquid methane. And they detected for the first time the waves on these oceans of methanes, right? So this is the first time that the waves have been observed on a body other than the Earth. The satellites, large satellites of Uranus, Neptune, and Pluto has a satellite, Charon, and Eris also has a small satellite. Now, Saturn has spectacular rings. This is a recent photograph of Saturn and its rings by a probe called Cassini, named after this gap in the structure of rings of Saturn called Cassini division. Right? Galileo was able to see that Saturn has this fuzz around it. He didn't know that they were rings. And for the long time, people thought that basically that's it. Saturn has rings and no other Jovian planet has those. But then they were discovered quite late. For instance, this is a photo of, I guess this is in a shadow, of Jupiter, and you can see that it has a very thin ring, but it does have ring. And the other two Jovian planets, Uranus and Neptune, also have thin rings. Then we have asteroids, and most of them reside in this region between the orbit of Mars, which is at 1.5 astronomical units, and the orbit of Jupiter at 5 astronomical units. So sort of the middle of it is at about 2.5 astronomical units away from the sun. So majority of asteroids live there, and as I said, they range in size from very small stones, but some very large ones, like asteroid Ceres, whose diameter is 1,000 kilometers, which is pretty big, and for that reason it's spherical in shape. It hasn't cleared its orbit because there are these many other objects moving around it, and for that reason they said, well, we should really classify it as a dwarf planet. Okay, but as I said, I still prefer to treat it as the asteroid. So majority of the asteroids live in the asteroid belt. There is a second group of asteroids called Trojan asteroids. There is one group of Trojans, and here is the other group of Trojans. And one group is 60 degrees, if I would draw the line from Jupiter to Sun, and then from Sun to this group of asteroids, the angle between these two lines would be 60 degrees. So one group is leading the Jupiter 60 degrees ahead, and the other group is trailing Jupiter 60 degrees behind. But there is another group of asteroids, so-called Apollo asteroids, that are actually, their orbits are highly elliptical, and they cross the Earth's orbit. Okay? So potentially they represent a hazard. So do some of the asteroids from the asteroid belt, because one of them can get kicked in towards the inner part of the solar system and can pass near the Earth. And not that long ago, there was one that passed between Moon and us. It was actually closer to us than the Moon. It passed at, I think, 300,000 kilometers or maybe 350, and the distance to the Moon is 388,000 kilometers. Okay? But there are these Apollo asteroids that are also labeled as NEA, and that stands for Near Earth Asteroids. Okay? So some of these guys can represent a danger to us. Then there are comets, as I mentioned before, and here is the photo of Hale-Bopp comet that was visible in 1997. And you can see, this is, I guess, between day and night photo. It's quite visible by the naked eye. And it has this, there are in fact two tails. There is so-called dust tail, and then there is an ion tail. And it turns out that comet's tail always points away from the sun. And the reason for this is as follows. As I mentioned before, their nuclei, in fact, are chunks of frozen gases. And we have some solid silicate material mixed in. So here is the photo of the nucleus of a comet. So when this chunk of ices and silicate material gets close enough to the sun, it receives enough solar heating that the gases start to evaporate. And the particles are being pushed away from the sun by the solar wind. Those of you who took astronomy 1P01 will recall that in addition to light and neutrinos, the sun also produces an outflow of electrical charges, mostly protons. And these charges move out. We saw that they cause, among other things, aurora on Earth. And we saw that their aurora observed all the way out to Jupiter and Saturn. Therefore, that solar wind extends at least to those planets, certainly beyond. So the solar wind, which is moving radially away from the sun, is pushing this material so that the comet tail always points away from the sun. In this photograph here of this particular comet, the tail is this way, so we know the sun has to be somewhere here. And indeed, you see the sun here either setting or rising, okay? So the comet's tail always points away from the sun. Then we have objects that are much smaller than the asteroids, so-called meteoroids that orbit around the sun. These are chunks of either silicate rock, or some of them are made out of metals, iron in particular, and a very small number of them are made out of carbon-based compounds. So if one of these objects happens to cross the Earth's orbit around the sun and hits the atmosphere, it produces a meteor, or as it's popularly known, shooting star. So unlike the comets that are visible for a long period of time, for days, weeks, or maybe months, shooting stars or meteors, they're just flashes of light that you can see. So most of them are quite small in size, like a grain of sand, and because there is not much mass, as they pass through the atmosphere, they experience friction, they heat up and start burning. And if there is not enough mass, they will burn out before they reach the surface of the Earth, right? So you see them, well, they still have enough material to burn, and then they burn out and the flash stops. But some of them are big enough that they can survive the trip through the atmosphere and land on Earth. Then they are called meteorites. So you have this chain of, it's one and the same object. Initially, it is meteoroid. When it hits the Earth's atmosphere and starts burning, it's called meteor. And if it survives the trip through the atmosphere, and if it is large enough, then it will hit the surface of the Earth, and that object we called meteorite. Often they are referred to as finds. Now, as I mentioned before, there are several groups of objects, and if they are so-called stones, meaning that these objects are composed of silicate material, just like the rocks on the Earth, if you find one in grass somewhere, right, you do not necessarily know that it came from the outer space, right? You can say, well, it's just one of the Earth's stones. However, if you see a piece of metal irregularly shaped, then the odds are that it is a meteor. or rather a meteorite. Because you don't find a piece of irregularly shaped piece of iron lying around that often. The best finds of meteorites are in Antarctica. And the reason for that is that in Antarctica, the ice cover is very stable. Arctic ice, it melts and then refreezes. So if there is a meteorite that was on Arctic ice, when that ice gets soft and melts, the object would sink in and then gets buried underneath the ice when the surface refreezes again. But in Antarctica, the ice is much more stable, so if you see a rock or iron, but even a rock on the ice in Antarctica, then you can be certain that it came from outer space. And finally, we have interplanetary medium, gas and dust. Just like we have gas and dust throughout the universe, right? We have it in our own galaxy. We have it in the space between the galaxies. So we also have the gas and dust in our own solar system. And the composition, mass-wise, is just the same as anywhere in the universe. It's 3/4 hydrogen and a quarter helium and the small amounts of heavier elements. Okay? So next time, we'll look at some of the regularities in the planetary motions, right? We will look at their masses and sizes in their densities, and again, you'll find out that the two groups, the terrestrial planets and the Jovian planets, are quite different.